The demand of commodities, fine chemicals, aroma compounds, proteins, or medicines such as antibiotics is increasing worldwide. However, conventional biotechnology production processes based on monocultures of microbial flora are reaching their limits. So how can new, more efficient production routes be created by scale-up that not only meet demand, but are also economically viable and sustainable? Roughly speaking, this is what the DFG Priority Program Interzel is about. We will be exploring this topic piece by piece with our podcast, Lab Whispers about Bioengineering. Today we are discussing the topic with Professor Dr. Ralf Takors. He is head of the Interzel Priority Program and chairs the Institute of Biotechnological Engineering at the University of Stuttgart. Professor Takors, it's a pleasure to have you here today.
Hi, great to see you.
Great to see you. Would you like to begin by telling us a bit about yourself, who you are, and how you became head of the DFG Interzel program?
Of course, great, thank you. So, I'm Ralf. I'm heading this program as I'm also heading here the Institute of Biochemical Engineering at the University of Stuttgart. So, my professional background, I was once trained as an engineer, frankly speaking, as a mechanical engineer. That is a long time ago. And then afterwards, I did a PhD in the field of biochemical engineering, and later on, even something which brought me much more into the field of biotechnology. So I made my German habilitation in metabolic engineering, even worked in an industry for a while. And then I took over the position here in Stuttgart. And as such, my colleagues and me, we decided to apply for that said research program, finally got it. And I'm the speaker, the coordinator of that. So I'm happy to do this, and hopefully it gave you a little bit of inside view about my career as well.
Yes, it sounds like quite a journey to get to this point.
Yeah, a little bit like this.
Yes.
That's true.
Wonderful. And now, how about if you explain to us in a few words what the program is all about? And also, why is it taking place at the University of Stuttgart?
Well, Interzell, which is the German pronunciation of this program, is about what we call the cell-to-cell interaction and the cell-to-bioreactor interaction. So now that may sound a little bit weird to those who are not in that field. Basically, we are talking about biotechnology, and basically we are talking about what microbes can do in order to produce goods that we need day by day. Be it commodities, which are chemicals, fine chemicals, or even antibiotics or other kind of stuff. And what we investigate in this program is how two interacting microbes can do this. That is the cell-to-cell interaction. And then the next is, once we have understood how these two cells are interacting, and then we try to translate that, what we have found in the lab, to large scale. And if I talk about large scale, you should think about bioreactors which have sizes of more than 500,000 liters and even more to produce these compounds that we are talking about. So this is all about in Interzell that we are investigating how such compounds can be produced. And well, how is that now, let's say, located here in Stuttgart? Simply because I'm the coordinator. And typically, the coordination is located there where the coordinator is, and I'm here at the University of Stuttgart. So this is then the logical consequence.
Yes, that makes sense. Well, I was thinking the scientific part is a major process, but would you like to tell me a little bit more about the scaling up process?
Sure. I mean, at the end of the day, if somebody has a great idea and somebody manages to have some microbes in his or her hands to produce something, then the idea is only good in case you're able to translate this idea from the small lab observation to the large scale application. And all that long way from the lab to the large scale is that what we call scale up. And you may think about that you're also shifting the environment, meaning that if you have the observation, then you are in a research environment, but later on you are in an industrial environment. And there a lot of stress is imposed on the cells, which they respond to, and not in the sense that their productivity is improving. Actually, it's the opposite. their productivity is going down. And this is why the research about how we can make these processes much more robust and how we can understand what's happening inside the cell under these industrial production environments, this is important to get these ideas really happening. And maybe one last word on this. We are right now in an era when we talk about climate change, when we talk about shortage of fossil resources, and speaking about biotech solutions, which intrinsically always make use of renewable resources, is something which helps us to make that shift towards a circular economy. And this is why all these production applications are essential to get to a new circular bioeconomy at the end to make our life much more sustainable and also to prevent further climate change. So that what we do has also a big impact on this protection of environment and to get our economy sustainable for the future.
Yes, well, that is certainly very important, especially in these times. I agree. So that sounds like a pretty big project. How is such a project funded?
Well, it is funded by the German Science Foundation. The abbreviation is DFG. And as such, these programs are intended to create something like a new, we call it nucleus, which is basically a basis of new ideas where people get together having the same idea and want to develop the said field further. And this is the basis of this priority programs, SPP, the abbreviation in German of the German Science Foundation.
I see. Well, let's get straight to the most exciting questions. What added value does the program achieve, and who would benefit from your research?
So I think at the end of the day, it should, of course, be the society who is benefiting because we do get tax money by German Science Foundation for doing that. And well, as said, the outcomes, the expected outcomes of our priority program is the knowledge, the fundamental know-how, how these cell-to-cell interaction of microbes which are producing something, how those can be measured, how those can be understood, basically to enable new processes, new production processes of the future. And the same holds true for the scaling up issue, because we want to translate the ideas from lab to production, not to keep them ideas or to trap those ideas in the lab, because then all the research which has been done until this point is basically not really worth anything if we cannot apply it, if we cannot make the products happen for the society. So at the end, the one who is benefiting, of course, is our society.
Right, that makes sense. What about obstacles? You come across many obstacles during your research. And how would you take on these challenges, or how do you take on these challenges when you do come across obstacles?
Well, yeah, being a researcher, frankly speaking, obstacles are a day-by-day routine because you're always stepping into a new field. This is, let's say, the key idea of doing research. And in particular, when we talk about research that is funded by the German Science Foundation, we talk about fundamental research. We talk about problems not having foreseen, not having observed by others, and there are numerous of these fundamental or let's say basic obstacles being envisaged by the groups in our project, having to do, for instance, with the cultivation of fungi, having to do with the investigation and identification of these cell-to-cell interactions, having to do with the use of acetogens, a particular group of microbes that we deal with under the conditions, and also having to do with mimicking large scale conditions in the lab. So a lot of these things require new solutions. And well, we do have talented PhD students who said, well, we want to do this. We want to do this research. We are such motivated that we go for the solution of these problems.
Can you share the status of the priority program and the progress made so far? I'm sure you have gained a lot of insights and successes. Could you tell me a little bit about those?
Yes, indeed. I mean, now we are in the second funding phase, which means that we have already passed 3.5 years of successful research. That was the first phase. And in that one, we focused on particularly fundamental research questions. Now, being in that second funding phase, we said, okay, we want to apply those findings of the first phase and to bring them on, let's say, on a higher level of maturity. So things that we have learned with respect to the interaction of cells, we now apply for producing antibiotics. We now apply for producing some organic acids, for instance, or we want to apply for producing them for other, we call them commodities, which are basically chemicals of large scale application. Or we want to apply them for mimicking large-scale bioreactors, which we are able to investigate to see how good our ideas are to really predict what's going to happen large scale. So yes, indeed, we made progress. We had lots of publications of the first phase, approximately 50 publications in the scientific society. And now we make use of technologies and develop them further in the second phase.
Well, that's great to hear that it's really progressing very well. This wraps up our first episode. In the following episodes, we will delve even deeper. We will get to know the different teams at Intercell and learn more about their exciting work. It has been a great pleasure speaking to you today, Professor Takors. Until next time.
Pleasure's on my side. See you next time then.
Thank you.